Okay, the position of a toy car moving back and forth along a horizontal track can be modeled by this equation, where time has to be positive. Determine when the instantaneous velocity of the toy car is the same as the average velocity of the toy car, specifically between 0 and 6. So this question doesn't say anything about mean value theorem, but that's what mean value theorem is about. When is the instantaneous velocity equal to the average velocity? Okay, so instantaneous, if you want to know the speed at an instant, well, this says velocity, and then this is position. So first off, remember that the derivative of position gives you velocity. So on the left side, we need to take the derivative, which would be power rule once and twice. You okay with the derivative piece? Okay. And then the average velocity, so the average rate of change, this is going to be like the slope formula part. So x of, oh, I'm not even looking at the right one. X of 6 minus x of 0 over 6 minus 0. Okay, so compared to the last question you guys asked, the derivative is a whole lot easier. This is a little bit more of a pain to evaluate x of 6 and x of 0. Well, x of 0 is actually pretty easy. 0 minus 0 plus 10. The denominator is pretty easy to find, but plugging in 6 into this function would be a pain, except notice they said feel free to use a calculator here. So I am certainly going to take that liberty, not risk losing what's going on because of an arithmetic mistake. That ends up being negative 152. So subtract 10, divide by 6. That whole side comes out to be 27. Okay, so this is a quadratic. So you could try to factor it, and I don't think it factors nicely. You could also use quadratic formula, which is always a last resort for me. But what's going to be a whole lot easier is to realize, wait, this is on the calculator part. Can't we just have our calculator solve this? So either graphing or the equation solver. I prefer equation solver. Math at the very bottom. One side of my equation says negative 2t squared minus t. And then the other side was negative 27. Go down. Just make sure you remember how to use this for when you need it. This is not the answer. This was the answer from the last time I used it. You have to hit alpha enter to get it to actually solve. Notice it says solve down here in green. And it will change this to solve what you have up here. So about 3.433. So one solution of that, because it's a quadratic, is about 3.433. And then that matched up with another card, so then I moved on. You got what you needed there? Okay. Anybody else that was going to ask that one? Need anything more specific on that?